What up, everybody? It's your boy, Mr. Nolan. What's going on? Alright, guys. Today we're going to talk about something that I find pretty easy. It is going to be dealing with some input and output tables. And now for some of you guys that really like drawing in art class, you'll be able to see my drawing, and then you'll be able to do your own today as well. Alright, so we're going to go over a couple of acronyms. There's one in science class, which I remember from when I was a kid in science class. How do you remember the color of the rainbow? Well, that would be the name Roy G. Biv. The R stands for your red. The O is your orange. The Y is your yellow. The G is your green. The B is your blue. The I is your indigo, and the V is your violet. So Roy G. Biv is the color of the rainbow. Now we do something similar here in math class. And when I was my first year teaching at Holmes High School, I liked how another math teacher used this. So I'm going to go off of what this teacher did. And whenever you get sick, you go to the doctor. Well, your doctor has his name. His name is XY. And guess what every doctor has? They have an ID badge. So the D stands for your domain. The R is your range. You're not going to really need that too much here in 6th grade, but you will 7th and 8th grade. So at least I'm going to show it to you now. The X is your X value. The Y is your Y value. The I stands for independent. D is for dependent. And then in small little words, we have this is your input. This will be your output. Now, if I were you, on your test coming up next week, I would definitely write this down. Dr. XY has an ID, and then I would also put the input and output. That way you know what value goes where. So if I were you, I would copy this down right now. Copy down the Dr. XY has an ID. Alright, I'm going to move on. I'm going to do a couple of pictures. A couple of nice visuals, because we're going to be talking about some input and output tables. The first one is a gumball machine. Okay? Well, guess what? You input a quarter. You then twist the little knob, and then a gumball comes down. Woo, 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 woo. And then it ends up right there at the end. And the output is, you get a gumball, right? Well, here it is. The input is the quarter. Then everything in the middle, you twisting the knob, and then the gumball coming down here. This is known as the work. That's what's going on in the middle, is the work. The output is, again, your gumball. What do you think about that picture? That's a pretty nice looking picture of a gumball machine, though. And then the other one is, again, I learned this from a teacher when I was at Holmes High School, and I thought, wow, this is amazing. The input. You have a dirty car. That's your input. The car wash, when it goes inside the car wash, it does all the soaping, the washing, all that. That's the work it's doing. The output is, you get a nice clean car, and you have a smiley face. Alright, so let's go ahead and do a couple of examples. So let's say we have, I'm just going to create this one. So on the top we have our input. Is my input my X value or my Y value? Go back to your notes if needed. Well, let's see. Input. Input would be my... Oh, there it is. It's my X value. So your input is your X. Here's where you're going to have your work. On your work, it's going to give you an equation. So I'll give you an equation here in a minute. Let's talk about this side. This would be known as our output. Our output is our y value. Let's use the equation x plus 4. And let's throw in some numbers. Let's go with 3, 6, 10, and 14. Just some random numbers. Okay? Well, what we're going to do is wherever we see an x, I'm going to input the x value. So instead of it being x plus 4, I'm going to plug in the 3 for x. But Mr. Noland, why are you plugging in the 3 for x? Well, here's my x value, right? All these numbers right here will represent my new x values. So instead of x plus 4, this is now 3 plus 4. So what is 3 plus 4? Well, it's 7. There's your output. Now what if your x value is a 6? What is 6 plus 4? Oh, well, that's 10. Well, what if you plug in a 10 for x? Well, what's 10 plus 4? Oh, that's 14. That's very good. And what happens if you plug in a 14? Well, 14 plus 4 would be 18. There's your input-output tables. Look at that. So let's go ahead and look at this paper right here. Alright, so let's look at this first one. It says my x value I need to plug in is now a 10 for x. So what is 10 plus 7? Well, the output then would be 17. Now it says plug in a 12. So 12 plus 7 is 19. And then plug in a 14. 14 plus 7 is 21. But look at this next one. 5x. Do y'all see how the 5 and the x are attached to one another? That means you have to multiply. And notice they put it either in parentheses here or they use the dot. Either one represents the same thing. So the next x value would be 8. So what is 5 times 8? Well, that's 40. Now let's plug in a 10. What is 5 times 10? Oh, well, that's just 50. And then what is 5 times 12? Oh, that's just 60. Again, all I did is I plugged in my x values for x in the equation. Okay. Now, what happens if you have to work backwards like you see here? Oof, man. This is going to be rough. Well, I'm going to show you two different ways. The first one is you can ask yourself, what minus 2 equals 7? So what number, take away 2, will give you 7? Well, some of y'all are going to say, well, that's 9. You could do that. Or you could do the opposite operation, which is what I'm going to show you right now. So I'm going to do this on the back. So let's see, we have numbers 9, 11, and 13. Again, you can tell yourself what number, take away 2, will give you 9. And some of y'all will be able to figure out that that is 11. Okay? The other way you can do it is you can write it as an equation. Y equals x minus 2. So your output, your y, is equal to your input take away 2. Okay, well, we already know what my y value is. It gives it to us right here. My y value here is 9. So 9 is equal to x minus 2. So guys, this is called doing algebra. If you're solving for the variable all by itself, you would do the opposite operation. So the opposite of subtract 2 would be to add 2. What you do to one side of the equal sign, you do to the other. Well, there's something we're going to be talking about later on. It's called a zero pair. 2 take away 2, doesn't that just cancel each other out? Well, yes, it does. That's called a zero pair. I didn't touch the x, bring it down. What is 9 plus 2? Oh, well, that's 11. Oh. Well, you're just telling me x is 11? Let's check it out. What is 11 minus 2? Oh, well, it's 9. It works. It works. And guess what, guys? You just solved a one-step equation, which is what we're going to be going into. Now, we talked on yesterday's notes what a variable is. A variable is a letter that will represent a number. This letter, x, represents the number 11 in this case. Okay. So let's see if we can try the next one. Actually, I'm going to skip the 11. Let's go to the 13. So y equals x minus 2. Y'all just told me the y value is 13. Okay. Well, we're solving for x, right? We're trying to get this variable all by itself. But attached to this variable is this minus 2. What is the opposite of subtracting 2? Well, that would be adding 2. Again, what you do to one side of the equal sign, you have to do to the other side. The 2 take away 2, zeros out. The x I did not touch, bring them down. 13 plus 2 is 15. So x is equal to 15. Now check your work. X is 15 now, right? So 15 minus 2 gives you 13, which was your output. Yay, it works. So I showed you two different ways of solving these. You can solve it using the one-step equation method, or you can just ask yourself the question, what number take away 2 gives me the output? Okay. All right, guys. I'm going to leave this problem, because you're working backwards, and all of these for you to do. Yes, these are two-steppers. These two are at least two-steppers. I want to see what you guys can do. All right, guys, you have a great day. Bye.